Thank you for joining us today. My name is Aaron Sloman. I'm from a company called SpeakTech, and this is Haida. He's one of our lead developers at SpeakTech. We're going to be here today talking about the MySpace development platform, and in particular, how we put REST on top of WCF. And it's a little bit bittersweet today. There's a couple of guys from MySpace we really wanted to have here today with us as well. Paul Walker, Vipak, some of the other team, but as you've probably seen in the press, our joint team out there at MySpace is under a lot of pressure right now to get this developer platform out. So in the next couple of weeks, everything we're showing you here today is going to be in production, and right now we'd encourage you guys to go and get a developer key and sign up and come and experience the platform. So just wanted to give a shout out to some of the other guys as well from the team that had to get their MIX trips cancelled in the last couple of days. What we're going to talk about today is not so much MySpace from a developer perspective, but we're going to talk specifically about how we worked on top of WCF to customize it to give us the features that we needed to be able to use WCF and REST to build the MySpace developer platform. So, you know, we're not going to go so much through what the MySpace API is. We're going to talk specifically about the extensions that we put on top of WCF to create things such as security, to deal with things like better URIs, to deal with some of the different protocol handlers that we needed. And we're going to take you through a lot of code. And so that's kind of the next hour, what we're going to cover. We are going to talk a little bit about what our requirements were, and then what WCF was able to provide, and then what we extended on top of that. And then at the end, we've got a couple of little sample applications that we have the source code for that we're going to put up on the web, and you guys can come and download them, and it's client and server code. So we're going to be giving you some WCF code, which shows how we put some of these extensions into WCF, as well as the client code for this chess game that uses the API, and you'll be able to come and see how we've written our test applications to stress the API, and hopefully out of that, you know, there's some nuggets that you can take back to your companies as well. Just to get started on the background here, how many people here were at MIX in 2005? Show of hands. There's a few. Old school. Excellent. I don't know if you guys remember, but we did a keynote with Bill Gates, and Aber and Ellen were up there, and we showed the first ever Vista gadget. And it was pretty neat. The Vista gadget was connected into the photo galleries at MySpace, and on Vista, you know, we're able to pull up and browse through profiles, and we had Bill Gates and Steve Ballmer up there, and we're able to go through. But one of the things that someone in the crowd yelled out when we were demonstrating it up on stage there was, open your API. So they thought it was great that we'd created our own little Vista gadget, but the developers in the community were screaming out for, we want to build on top of your framework as well. So over the last 2 years, there's been a pretty extensive roadmap for MySpace. It's not easy when you're the largest social network in the world to suddenly open up all of your shared services and your caching layers and your databases and deal with things like privacy and security and spam and things like that, and do it very quickly. And so what you're going to see from the API and some of the things that we've put into it are really things to make sure that we have a very robust development environment for the developers. And one of the things that I can say on behalf of our client MySpace is, even in the last 3 weeks, we've had phenomenal interest in the platform. And so it's a very, very exciting time right now for what we've seen. So developer.myspace.com is where we have our REST API. We have our open social containers, code examples, and you can go and get a developer key and upload your applications there right now today and put them on your profile and start sharing them with your friends. So just a little plug there for where we're at in the project. And within the next 2 weeks, you'll see all of this stuff in full production. Going back to, you know, circa 6 months ago, when MySpace started talking about opening up their API, what were the requirements that we started looking at as we started looking at the technology and the platforms? It was a very interesting sort of set of due diligence that we had to go through as a team. One of the things that we were really shooting for was an independent API for any type of client. First-class citizen for mobile, first-class citizen for Mac or PC. We didn't want to adopt protocols that were kind of heavy. We needed scale. One thing that's a little bit unique about the API and the open social framework coming out of MySpace right now is, we're expecting tens of millions of transactions an hour through this API. MySpace has millions and millions of concurrent users, and each one of those applications with a bit of AJAX in it calling back against this API is going to generate quite a healthy denial of service on us if we don't think about this really well. So one of the things that we were looking for was a lightweight API and a very scalable API. So that was one of our key requirements. The other thing is that the standards are changing so much right now. And as an API provider, for a developer community of thousands, we wanted to be able to keep up with the standards. And so while we have moved into a REST API for now, we don't know where that's going to go. In 1 year, 2 year, 3 year, 5 years, with data portability coming in now, and all these new standards coming out. And so that was another one of the challenges that we were sort of faced with as we started building on top of this. And so hopefully what you'll see today from our code is that when we build it inside WCF, we build it in mind that the transport may change. Or we may extend it. Maybe we'll come up with some more use cases around customers or clients or business use cases where, REST may not be enough. We may need to do some other things too. So a lot of prototyping, a lot of testing over the wire, a lot of scalability testing, a lot of time with the WCF team. The end result was a WCF platform over REST. And what I'm going to do now is turn it over to Haida, and Haida's going to really step up and show you the nuts and bolts of how we did it and what the API looks like.
Thank you very much, Aaron. Good afternoon, everybody. So I want to jump in on this, and as Aaron said, the goal of this presentation is to offer very cool solutions for some of the problems that we faced, and to offer some source code that people can download. Those of you who are API developers and they want to go RESTful and adopt different standards that are out there that we've adopted, you guys can go ahead and download that code and start playing around with it and have an API ready to go. But before we show you the code, let's start off with some concepts that are basic to our RESTful API. How many of us in here are familiar with REST? And how many of us in here are familiar with WCF and have worked with WCF? Now, how many of us in here have actually implemented a RESTful service using WCF? So I see like 1 or 2 hands. And I think, and Vittorio here, who is the architect behind all of it, and has been a tremendous help for us getting this up. So what we boast is that we've got something ready to go, a solution that we've experimented with and traveled with. Principles of REST. It's pretty common sense. I don't want to spend too much time on the topic because we could spend an hour or so on REST. But in a nutshell, there are a few principles that are very important that you have to take away with when we say a RESTful service. The first and most important thing is the URI, the concept that you have a universal resource indicator, whereby there's an address, whereby we can go and take and make methods upon this resource via a URI. The reason why the URI is so important, and it's probably intuitive for all of us, and I like to give an example. If we're on Live Messenger and one of your friends actually sends you a link with a video, and you go and you watch it and you like the video, you forward it on to 100 people on your buddy list, all of a sudden you got 100 people instantaneously watching a video. The reason why that happened, why so many people were able to see that resource, is because of that address, that URI. If I came in and I posted like a 10-step process, hey, you got to log to this site, type in this search, blah, 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 then you can watch the video, very little people will be able to see that. So that ability to rapidly seek a resource is made available through your URI. Another key aspect of REST is the HTTP method. REST is built with the assumption that HTTP is its protocol. And so it makes use of the HTTP methods that are available: get, put, post, delete. And it relies on those for the different types of transactions it wants to take. Another key component of REST is its connectiveness. And the connectiveness is actually what makes it so successful on the human web. For example, we go to a news website, you see a list of articles, and you click each one. As you go through, you're clicking other ones. All those hyperlinks that you see, those are actual URIs, and they're connected through URIs. And so that connectivity has played into the success of the web. And so the proponents of REST say that, for RESTful services, that is, they say that just like REST was successful for the human web, it'll be successful for the programmatic web. And so they push that, and we're believers in that. If you guys want to go into more detail, Roy Fielding drafted his dissertation. The link is right there, and he's the one who came up with the name REST. So, what are the benefits of having a REST API? Well, one of the most important ones is it's easy to start off. It's easy to make calls to this. There's a low barrier of entry. We don't need a toolkit to get started. All we need is the HTTP protocol, which is ubiquitous. All we need to do is do get methods and have a URI. If we need to do updates, we can do a post or a put, and we'll come across some of these different methods later on. Another key aspect and key benefit is it's really flexible when you want to get different types of formats coming back. I can use a RESTful web service to pull back XML. I can pull back JSON. I can pull back, and we experimented at MySpace with flash binary data. We were able to do all this very easily, and actually we used it with WCF. REST is also the best choice when you don't know what type of client you're going to have. So we can assume that most of the clients, if not all of the clients out there, know how to use HTTP. And we don't have to worry about, okay, does this client have a SOAP toolkit? Does that client, can that client make this request? Because HTTP is so widespread. And so we can trust it. Now, there is an issue of some methods which, like a put method or a delete method, which aren't supported by clients. And we'll address that. We'll address how we bridge that gap. So why don't we go ahead and take a look at a RESTful API in action. Now I'm taking you to the developer.myspace.com. Again, like Aaron stressed, you guys can go on there, create an application, get a token, and start developing your own, very own applications that'll get hosted on MySpace. And we have a lot, the team has developed a lot of cool tools that you can do, and this is one of them that kind of displays what I'm talking about. I'm not sure if people can see it as well back there. So let me make this a little bit bigger. So in here, you'll come in here, this is our API developer tool. I'm logged in, so you can see my user ID here, pulled from the cookie. And these are the different resources that we expose currently with MySpace. You can get my data, you can get my profile data, my friends, albums, all the way down the list. And there's different ways and different parameters that are required for each of these requests. Now, you'll see here, I made a request, and you can see this is the URI I made it to. It's a simple URI. In here, we have a .xml extension. If we put .json, this whole URI would return the same data, but in JSON format. See, this is the response we have. It came back in XML. If you typed in .json, it would come back in JSON format. And you can see here, the method is a get. We have a couple of headers that we added to it for authentication purposes. And then the response comes back with the status code, which is also very important to hang on to when you want to implement RESTful services. That's an example of a REST API that you guys can go ahead and play around with and look at and see. Oops. So let's go into WCF and how WCF implemented its RESTful architecture. This came out actually in WCF 3.5. I remember when Vittorio came down to MySpace and we discussed a lot of these new features, and we actually started developing this stuff with the beta 2 bits. These new features that we're talking about didn't even come out with 3.5 beta 1. They came out with beta 2, and we downloaded them right away and we started developing against them. Key to it are these things that I have on the slide. The first and most important thing I should say before, a WCF class is just a normal C# class. When you put certain attributes on it, it becomes a service. It's really easy to transform a normal class that we're used to into a service. And I'll show you some of the small little attributes that you add. One of those attributes is a webGet attribute. If you put this webGet attribute around a method, instantaneously it becomes a RESTful method, a RESTful API call. The URI template that's associated with that webGet, that allows us to map a certain URI to a method in a class. And I'll show you that in the code right in my next demo. Another important thing that came out with the 3.5 bits, if those of us, and I saw a lot of people familiar with WCF, they came out with a new binding. That binding is called Web HTTP binding. And basically, if those of us who are familiar, we know how easy it is to switch a binding. You can switch from HTTP binding to basic HTTP binding. Well, they introduced a new binding called Web HTTP binding. And so you can take your existing code and make it RESTful by just changing this binding. So right out of the box, you can get a RESTful API without having to worry about changing all your code. And you'll have to add some attributes so that you can expose the URIs per method call. But the underlying business logic and service logic is unchanged. Another key feature is the operation context. The web operation context it's a class that allows us to manipulate messages that come in and messages that go back out. And when I say manipulate, I mean manipulate them in a RESTful way. For example, if we want to send back a non-authorized exception, let's say somebody tries to enter into our API and they're not authorized. Well, in HTTP, we have a status code called 401. It's a non-authorized status code. We would like to send that back to stay RESTful and authentic towards the RESTful principles. We would like to send back a 401 exception. And so what the web operation context does and how we leveraged it in our API was to be able to manipulate the status codes, the outgoing headers, and the outgoing payload or entity body that goes back to the user in order to be as close to the REST model as possible. And it made it very, very easy. And by the way, you can access web operation context anywhere in your code. So you can figure out, okay, I'm in this context. We also extended it. Later on, I'll talk a little bit about it. But we extended it so that we can insert data that is accessible across the service API. I don't want to talk too much about this because I believe tomorrow Justin Smith will be giving a presentation at 10:15, and you guys can jump on board building applications and services with .NET Framework 3.5. So let's look behind the scenes and see what we got here. Okay, so like I said before, we're just dealing with C# classes, interfaces, and classes. And this shouldn't be too unfamiliar to people here. We have here an iChess service. So I guess I should give a quick intro about what we're talking about here. Some of my colleagues at MySpace are chess enthusiasts, especially Paul Walker. And he wanted to do an API that's built around chess, although I have to admit I'm very ignorant about chess, so if I do some moves on here that's illegal or whatnot, please forgive me. I worked a lot on WCF. I didn't work much on chess. So here we are. We wanted to come out with, we can't obviously give you our proprietary code for MySpace. But what we did was we took a lot of the major features and extensibility points that we put into the MySpace API, and we created our own API, and we called it REST Chess. And now this stuff, Paul just sent me a message that this stuff is now available online, and it'll be available for download, and I'll give you guys the links towards the end of the presentation. So here we go. We have this iChess service. All we did was set an attribute on top on this interface to indicate to the WCF runtime that this is actually a service that we want to expose. Over here, we got a bunch of operation contracts, and like I said, these are just normal interface methods and properties. Here, we have an operation contract, and this is what we were talking about before. We have a web get, and one of the properties of the web get attribute is the URI template. So have a look at this. In essence, what we're trying to say is, WCF, when we have a message and a request coming over our service at this URI, games / and the curly brackets indicates like a placeholder. If we have something come on this channel, please map it to get game. That's essentially what's happening. We have a listener that's listening on that URI exactly, and it's going to map it to the implementation code. Also here we have some certain properties that are really helpful. Over here we're saying, okay, we want the response format of this to be XML. We could easily change this to JSON. And out of the box, WCF will serialize the class that we're sending back. In this case, it's the chess game class. It'll serialize this to JSON without us having to worry about it. So this is not enough for a service. This is just the contract. This is what we expose. The service itself, for the WCF enthusiasts in here, all it has to do is implement this iChess service. And in here, I've just put a breakpoint over here at getGame. GetGame expects one parameter, and we have a chess game provider that sends this ID back to the database. And in fact, if you guys download the code, you'll see we built this entire database connection over LINQ. And it's a pretty cool, those of us who are trying to get introduced to LINQ, all of it's using LINQ, and that's thanks to Paul. Paul put in a lot of time to put out the whole thing in LINQ. So our chess provider will pull back our contract, which is our data contract, which is chess game, and it'll send it back. So let me show you how that works real quick. Okay. Let me just run this real quick. A second. Okay. So here we got a little client app that I have, which is, I'm not a UI developer, and I don't boast that, so please forgive me if it's not as pretty as you wish it to be, but this will do for us. Oops, did I just close it? Yeah, I did. You know what? I can display it here. So we're making a connection right now, and it's actually, I should type in the URI so you guys can see it, but the breakpoint hits right here. That's the URI. I'm sorry I didn't expose it. So the URI just says games/MIX08, and right now the way we're exposing the XML that's coming back is the representation of this chess game. That's a famous chess game that took place, I don't know when. Again, I'm no chess master, but the moves are there. If you can look, you'll see the white opponent is PJ, and the black opponent is Hyder. That's me. And then we have a bunch of moves here. And you might ask, well, what does all this XML mean? We actually found a XML notation that's out there. I don't know if you guys have heard of algebraic chess notation. Well, there's a new open standard that's coming out called Chess GML, and this is kind of a representation of that Chess GML. So this actually shows the different moves that have taken place on this game. If I came here, I can look, I want to see, okay, what did white do on the first move? We can go, we'll pull back. Using URI, we see that he made this move. And apologies if this doesn't make any sense, but E2 is a position on the board, E4 is a position on the board, C means it's the white player, and N is the piece, which is a pawn in this case. So let's go back to our presentation. So you guys saw real quickly some of the easy ways to create a service, build those contracts out, and send back easy code. There's much more to our API than this. We had a lot of stuff that we had to deal with, a lot of problems that aren't solved right out of the box. But the way, this is my opinion, the area that WCF shines is the ability to extend it, to insert into it, to build on the stack at a high level, so you can do things high and kind of abstract it away from developers who just need to work on infrastructure and business logic and service code. So one of the areas is having flexible URIs. We wanted to have an ability to have various extensions like .xml, .json, to have liberty with that. At this point, that's not supported. And if I can give any advice to the WCF team, Vittorio here right now, is that we would like to see the URI template that we showed support different extensions. So that way we can map these extensions accordingly. Bridging low-rest clients. So I kind of alluded to this before, and I'm going to talk about it a little bit more now. When we have a client that cannot do a put, an HTTP put, or an HTTP delete, we want our service to remain RESTful and to support these methods, but they can't do these. So in the community, they call those people to be low rest. They can only implement low rest, while a high rest model will be a service that can take all HTTP methods. So what we needed to do is create a solution to solve for those people who can't do full high REST calls into our API. We also needed to add authentication through digital signing. That's not available right now in the WCF bits. So this is some of the stuff we worked on. We wanted to extend the operation context, so that way we can pull data from a request and perpetuate that and allow our service developers to grab that context whenever they want. We also wanted multiple representation formats. So I mentioned that we kind of experimented with binary flash formats. We wanted the ability not just to send back XML and JSON. We wanted the ability to send back any formats that are out there. And we've kind of been experimenting with different formats that are out there right now. Recently, new words coming out, JSON-P. So some of the developers were working on a JSON-P serializer and format. So these are the type of things that are not readily available right out of the box. Another thing is RESTful exception handling. This is one of the things that we kind of boast about because we want to gracefully handle exceptions like in any other application. But the unique issue here is we can't just send back 500 errors. We can't just send back a string and a stack trace. We need to be able to catch these exceptions and map them to a REST HTTP status code. So, like I said earlier, if somebody violates his authorization, we shouldn't just send him a 500 error. We should send him a 401 error. If somebody makes a bad request, like inputting incorrect data, we should send back a bad request HTTP status code. If somebody creates a resource, we should send back a 205, which is a created resource, and so on and so forth. We wanted the ability to handle exceptions gracefully, and we built an entire engine for handling that, so that way you can just easily throw an exception like you would do in any case, and it'll actually convert that exception into the proper status code that you want and send it gracefully back to the client. I'll show you how that would look real quick. So let's say somebody... So in this case, we have MIX08. Let's take the breakpoint off. MIX08 is a legal and existing resource out there. And so we get this XML back. MIX09 doesn't exist yet. So it's going to throw an exception here. We have this exception called resource not found exception. That's all he did in his code. And that actually translates back to our client as a 404 error, and we have some custom messaging that we have in here. No game found for game title equal MIX09. So that's something we're proud of. That's something you guys can look at and enjoy once you guys download the code.
Quick question.
Yeah.
Is the key assumption with REST that you're doing XML across the wire?
The question was, is the key assumption with REST that you're doing XML across the wire? And the answer is, actually, we don't specify in REST what type of representation. It's not confined to XML. It can be JSON. It could be any type of format that comes out in the future or in the past. HTML. Like when we go visit a website, we're actually using the principles of REST, and it's coming back as HTML. So it's not confined to a specific format. Although XML is widely used, at MySpace, we had to support JSON because many of our clients are actually using JavaScript apps. And so JavaScript can consume JSON far better than it can consume XMLs. So supporting that was critical for us, and it was actually very easy because WCF supported serializing to JSON very easily. We didn't have to do that work. So some of the problems that we had with URI templating, I mentioned earlier. When you host a WCF service in IIS, those of you who have practiced with it, you have to have a .svc file. That's basically the endpoint by which you make calls into the API. For us, we didn't want to have that .svc file available and exposed all the time. We wanted to make it much more cleaner. And so we ran into this problem. And again, one recommendation to our friends is that at Microsoft is that they help us solve this problem gracefully. The other thing I alluded to before is the extensions. We wanted the ability to type in extensions into the URI and not to have to worry about URL rewriting and all these other painful things, especially if we're developing with early IIS, earlier versions of IIS. But we found a workaround for this. And with IIS 7, it's really cool because importing a HTTP module is very easy. It's become a lot easier than the previous versions of IIS. So what we were able to do was prepend and map all requests to our SVC file using URL rewriting. So it was not seen in the URL, but to our service, our endpoint was being hit correctly. We were also able to take the extension and map it into a URI hierarchy, so that way we can go around that extension problem. I'm going to show you how we implemented the IIS solution real quickly. It's very simple. It was a couple lines of code. So here, all we did was create the HTTP module, and in here, when the begin request starts with the context, all we did was map it to chess.svc, and all our service calls were mapped accordingly. So it was a simple, fix with IIS 7. It was a lot harder to fix it in 5.1 and 6.0, and we had to do various other ways. But with IIS 7, it worked out. Oops. Okay, so I kind of alluded to this a few times already. High-low rest. And what's the big deal about it? Again, people want to make put requests, but let's say their client software won't allow them to do that. Let's say there's something that's blocking them from making a put request. We want to be able to support them so that, hey, you guys are in the low rest community, but you still can use our service. So some of the main figures in the REST community have given recommendations about how to make your service high-low rest bridged. And two ways are to when you make your request, let's say you intend to make a put and you want to send a payload with it. You would instead do a post. But in your URI, you would add a query string parameter called underscore method equals, and then you would indicate what actual HTTP method you want to send. So in this case, it would be, let's say I want to do a put, but I would actually do a post. So the post would send back, and then the query string parameter would say underscore method equals put. So in that case, our service, being a high-low rest bridged service, should be able to interpret that method query parameter and convert that request from a post to a put. So it inserts, so it flows freely into our service. Or you can use a header, HTTP header, and the established or the one by convention now used is a custom header called X HTTP method override, where in it you would actually put the method name that you're trying to override with. Now, how do we do this in WCF? This is one of the shining points, like I said, that WCF has. There's a whole subject in WCF called channels. And I can't talk about it in detail because it's a huge subject, but I can summarize by saying that channels are basically interceptors that are high in the infrastructure of the WCF runtime. When a request takes place, they are very high up there. And they modify incoming messages as they come along, and they pass. One channel passes to the next channel, passes to the next channel, until it finally reaches the last channel, and then it hands it off to our service code, the code that we saw in the breakpoint. So WCF is so extensible that you can actually introduce your own channels. You can introduce, all right, I want a channel to work right before it reaches the service code to do some manipulation of the message. And this is actually what we did here. What we did here was we created a custom high-low rest channel that will intercept the request and check for this header or this parameter. And if it exists, namely the HTTP method override or the underscore method, if those exist, then what we'll do is we'll modify the message to have that HTTP method rather than the one that it came on the wire. And what that does, when we pass that message down the channel stack, it reaches our code as if it came in as a put. So the service developers, me, who I'm writing the business logic, I'm expecting a put to take place. I don't have to worry about it. I don't have to worry about the client being a low rest because our channel intercepted it and manipulated the message, and to our service, it looked the same. So let's look at the code. Let's look at the code. So when you guys download this code, you'll see a lot of code here. with channels. So channels it's a big subject. There are many places that you can customize the behavior, but in practice you only have to pick the areas that you need to change. And so in here we have, typically we just delegate to the channel base. So in here we have a bunch of overrides, a bunch of methods and members that we're implementing. But for us, all we have to do is expose one little method, and that's in the HL channel. So in the HL channel, we inherit it from REST chest channel, and in here we override one method called onReceive. So this onReceive takes the message object. That's the message. That's the cornerstone of every WCF call. It contains all the values of the request. And what we do is we created a message formatter. It'll essentially take this message and format it. It'll go and look for the headers, it'll look for the parameters, and change the HTTP method. And then all it does is it passes it right back on the stack and continues going further. So those of you who want to kind of dive into the details of that are welcome to. I think, we have so much to cover that, it's probably better that you guys do it on your own. The other subject that we had to deal with when we talked about authentication and digital signing, again, we don't want to have to control all this authentication at the service implementation level. I don't want all our developers on our team to have to worry about, is this guy authenticated or not? We don't want them to care about that. In fact, what if we change the way authentication works? What if we adopt a different model? And currently at MySpace, we have two different ways to make calls into our API. One is through server-to-server calls, and one is through open social calls. But both of those types of calls coming from two different areas, from two different clients, from two different environments, they both get channeled through one authentication mechanism. And then once they pass that and they're legal, they end up in the service code, which is the same service code for each one. So that was the whole idea behind it. We want to architect this so it's very easy to turn on and turn off our authentication and modify it without having anybody to worry about it. Also, we wanted it high in the runtime, so that way and we expect the majority of people who are just like testing and getting started with the API to be making illegal or unauthenticated calls. We don't want WCF to have to create this entire stack and then figure out at the end, okay, it's unauthenticated, kill it. We want this to happen early on. And as Aaron alluded to, we're expecting an immense amount of requests, having MySpace being what it is. And so we, scalability and efficiency and all that, it was very, very important to us. So a standard has come out, and it's fairly new. Anybody have heard of OAuth before? Great, I see a couple hands. So OAuth it's basically an open protocol to allow secure API authentication in a simple and standard method from a desktop, from a web application. It's very, very RESTful, and it uses digital signing as the way of authenticating. You guys can go to OAuth.net to look at the standard, but you can also, once you see the standard, you can also download our code, and we have our OAuth managers that will validate requests based on the OAuth standard. So what we ended up doing was we revisited the custom channels, and we said, look, let's build a channel just for OAuth. And that's what we ended up doing. So why don't we look at the code? So again, as you guys saw earlier, I simply made an OAuth channel this time. It inherits from REST chest channel. And we just override one method, which is the onReceive method, where a message comes in. And in here, we construct an OAuth context based on the message. So what this OAuth context does, it takes the message, it extracts from it all the parameters required for an OAuth call, whether it's from the headers, whether it's from the query string parameters, whether it's from the entity body. And those of you who have read the OAuth standard, you'll see that people can authenticate via their query string parameters, they can authenticate via the headers. So our OAuth context, it figures it all out, and it creates the context. Then our OAuth manager goes and takes that context and validates and makes sure that all the proper things are in order. It makes sure that the digital signature matches the digital signature that was passed in over the web. And then it goes and says, okay, you're authenticated. If you're not authenticated, we created a cool REST error message that, again, like we talked about earlier, in this case, we send back a digital signature exception, which is, in our case, it's a 401 error with a special message saying that you have an invalid signature. So it just goes and it gets sent back to the user. So why don't we look at our demo and see how this works. Now, in my previous use of this, all my requests that I did were not signed. So I made this request here. This is the actual request. If I click this, this is the actual request here. So it's not signed, okay? So if you see here, the URI is just empty. It's just a get to one URI. Now, I want to enable OAuth. And another cool thing about WCF is it's so easy to modify the configuration, even in the things that you extend. So how do I turn on OAuth? Just go down to the web config here, all the way at the bottom. And I have an OAuth channel that I've commented out. You guys see here, this is the high-low res channel. I've commented it out. Now I'm going to uncomment it. And obviously this maps to the code that I showed you. I'll save this and so now that we've attached, I'll go back to the OAuth code, the OAuth channel, so you'll see where the interception takes place. I'll put, let me see here. Okay, there we go. So, I'm going to make this request now. It's going to get sent over the wire. Because I've enabled OAuth, it stops here. The breakpoint hits. And it's gonna, if I step through it, it's going to go and it's going to fail. Authentication didn't take place. And it's going to throw an exception, and the exception is a bad request. Why? It says missing required parameter OAuth consumer key. It's missing. So very simple. I just turned on the channel by uncommenting something, and the channel appeared, intercepted the message, and did some logic checking. And before it could pass code all the way down to the service layer, it said, hey, you're not authenticated because you don't have the OAuth consumer key. Now, in my client, I made it easy. I click this button, and automatically my request now will actually be signed with OAuth. So now if I click this, boom, it gets to get gain. It passed through the channel because it was authenticated correctly, and we get back the URI and the representation that this URI holds, and that it was just as easy as that. So a couple things that I wanted to show with the API also that you guys can play around with. So like right now, I created a...
Hey, Hyder.
Yeah.
Before you go, you just want to highlight the key here?
Oh, yeah. Okay. Yeah, so Aaron reminded me here. This is the OAuth, this is how the OAuth request would look now, where we have the OAuth consumer key. This is the consumer key that actually when you guys sign up at MySpace, you'll get a consumer key, and that's what you'll be using. And you'll have a consumer secret, and that's what you'll sign your request with, based on the OAuth standard. And then you'll have the signature, the method that we're using, and the different parameters that are involved with the OAuth request. All that stuff right now is passed right now through the query string parameters. And the query string parameters, once it hits the custom channel, it'll extract all that and validate and make sure that this is a proper OAuth signature and proper OAuth request. So I'm going to go ahead and show you that I created a game, and let's turn off these breakpoints. And right now, my game is empty. I have no moves. Let's say I wanted to make a move. I kind of made a quick thing here where I can say, and again, I'm no REST expert, so I don't know if these are legal moves, but I'm saying I want to move the white chip on turn number 1 from A3 to A5. And let's say it's a knight. Okay? I'm going to generate the GML for it, or chess GML. This is what the standard says. The standard says, okay, if you want to represent this move, this is how you're going to represent it. So in our case, I go over here and I'll say, hey, you know what? I'm going to do a put, and I'm going to paste that in, and I'm going to make this request. Oops, that's wrong. I have to make it to the actual URI. So I'm telling it I want to make a put on the first move for white, and this is what I'm moving. This is how I'm moving. So it goes, and it moves, and it returns it back. So now if I did a GET request on this, this is the value that I get back. So now out there, we have a move that took place using this RESTful put. If I looked at the game now, it should show this move now. So we have this first move, and this was the move. Okay? So now let's say it's black's turn. So I go over here, and yeah, these are illegal moves, I know, but it works out. I don't know if you can move the king that early, but... So, yeah, I have to admit I don't play chess, so here we go. We're going to do a put now, and let's make the put to B1, because it's black, and it's the first move. We're going to make a put. Send the request. Boom. We got the reply back. It was a 200, and it sent, in our case right now, we're sending back the same. Because this is the URI is represented as B1, the first move that the black turn did. We send back that resource back. So again, we can come over here, do a get, and see, hey, we got another move here. So our game starts to take place, and we have this. We're hosting this in a database where people, if you can write a totally cool user interface. All you have to do is make these requests, and you can actually do the game and go through it. Albeit, we still have some rules. Rules. The rules engine has to go in there, and we're almost complete with the entire source code for the rules. But for the sake of this demonstration, which is for WCF and RESTful service, I think you guys get the point. I think my lack of chess knowledge will be made up by what we've been able to demonstrate. I also want to show what happens, let's say, if a client can't do a put. So let's say I want to, now it's turn number 2 for white. So we're going to do, let's say it's the same request. Let's say he wants to do a post. What's going to happen? We're going to get an error back that says the method is not allowed. Okay? So that method isn't allowed because we don't support it. We don't have that mapped right now. What would I want to do here? I would want to go ahead and do this. I can come here, and this is where high-low rest comes in. Method equals, method equals put. And so since we have that channel running in the background, when we do this, this message actually gets translated into a put message, gets delivered to our WCF engine, or our WCF service code, and it works as if it's a put. So now if we go, again, back to my game, no game ooh. See, this is a good error. 404 error comes back because we spelt it wrong. You guys thought I got killed there, but so that was supposed to happen. All right, so we do a request on Hyder again, and we see that there's another move that took place, and here's the move here, and I apologize if it's hard to read it, but this is the move here that just got added, and that was done through a high-low rest bridge. So that kind of demonstrates that. Again, all these calls are running over OAuth. If I try to do this and I stop signing it, boom. Sorry, bad request, you can't do it. And it's as easy as commenting out that line of code to enable or disable that. And on our website, restchess.com, we're going to turn off OAuth so that people can make these requests and play around with it without having to worry about getting that protocol up and running, because it is a new standard. And if you want to download our source code, you'll be able to see the OAuth signer, the OAuth digital signer class. It'll do all the work for you. And OAuth API facade class, which will take a URI and take a consumer key, the consumer password, and then create an OAuth request for you on the fly. All right. Now, I want to show a quick Flash application that was developed by Vipak at MySpace, Vipak Lay, and he kind of put together a quick Flash, rich internet application that could have equally been done in Silverlight, but the purpose is to show how easy it is, and he did it in very quickly, in a matter of hours, where he could put together a quick application that can actually make calls to our API. So let's say we did this, so right now there's a pre-programmed game that he has installed that has some moves, and so if we did let's reload this. So here we go. Oh.
VPAC's game's broken.
Yeah, VPAC. All right, so let's see it on the live site. Let's see if it's working good. If we click here, there you go. You saw the pawn move up. It made this. This is the request it sent. It did a put with this URI. I'm sorry, this XML. It got sent to the server, and that got registered there. If we did another move, that guy moved, and in this case, it was the black player. Then this got moved. I don't think that's legal, but that moved. And then we got a couple more moves going here and there. And we challenge everybody out there to kind of put together some sort of app that'll work, look better than my win form that went up there, which is not as attractive. But for us, we consider ourselves the nose tackles and the offensive linemen of programming, so we don't get all the credit, but we definitely love what we do. So in summary, MySpace development platform has been launched. It leveraged REST as a philosophy and as a way to service their API to the world, and we use WCF to do all that. WCF is very powerful. It allows very strong API development for the web platform, as we saw. It's very easy to get it up and running. It's very easy to configure it, and it's also very easy to extend it if we wanted to. We saw what we could do with custom channels. We saw what we can do with exception handling, and some things we didn't even show you because of the time constraints, like behaviors and custom attributes that you want to do. All the demo source code for restchest.com is available at restchest.com. You guys can go ahead and go there, and right now go to restchest.com/index.html, and that'll give you the actual source code. And MySpace's API is available now. Please, we encourage you guys to go visit developer.myspace.com and play around, create yourself a user ID, get yourself an application and a consumer key, and start playing around. You can make applications very easily now. You can make it using JavaScript calls. So go ahead and get started, and we encourage that.
Yeah, and there's a lot of test harnesses up there too for the apps. So there's a test harness for OAuth. There's one up there for the WCF services too. So just by signing on, all of the channels will be exposed, and you can just go through the selector and do tests and get it back as JSON or get it back as XML.
So thank you very much, and